So, hi guys, I'm Kyle Steven F. Kaime, and today we're gonna solve some great circle setting. So, we have a problem here. Find the great circle distance, initial and final course from 10 degrees 25 minutes south, 90 degrees 12 minutes east to 39 degrees 27 minutes north, and 50 degrees and 10 minutes 55 degrees and 10 minutes east. So, find also the position of the vertex and the longitude in which the GC track crosses the equator and the course. So, first thing, write your latitude A, longitude A, and latitude B, longitude B. So, here, latitude A, 10 degrees, 10 degrees, 25 minutes south. Then, longitude A is 90 degrees, 12 minutes east. Then, latitude B, 39 degrees and 27 minutes. And for the longitude B is 55 degrees 10 minutes east. So the second step is draw your GC track. So analyze your latitude. So first point A is here. So dot A, this is south. So it is 10 degrees 25 minutes south and 90 degrees 12 minutes east. So then our latitude B is 39 degrees 37 minutes north. So it's probably here. Latitude B. So label that point. So 39 degrees 27 minutes north and 55 degrees 10 minutes east. So as we can tell that the equator of this uh, from point A to point B, we will cross the equator since we will referencing the North Pole. So from A, gonna draw our easy track. So here we will reference the North Pole. So label your North Pole. So North Pole. So from lot A to lot B. So the equator will be located here. So around here. So draw your equator and then label it. So this line is the equator. So let's proceed. So I will be finding your D long. So D long. So here D long. D long. So we have our longitude A. We have our longitude A and longitude B here. So since we have the same signs, we're gonna subtract this one to get our D long. So calculate 90 12 minutes minus 55 degrees 10 minutes. So we have 35.02 minutes. So this is our D long, and this is our P also. So let's proceed in getting our great circle distance. So using the cosine formula, cosine law, cos AB cos B times cos dot A times cos lot B plus or minus sine lot A times sine lot B. So input your given values. So cos P is our D long. So cosine 45 degrees 02 minutes times cos latitude A. What is our latitude A? 10 minutes, 25 minutes. And then times cos lat P. What is our cos lat P? 39 degrees 27 minutes. And then for this problem, we're gonna use sine. Why we're gonna use a minus sign? So why minus? So as you can see here, if your latitude your latitude A, latitude B has the different name. So in this problem, we have different names. So lat A is south, then lat B is north. So since we have different name, we're gonna use minus in getting from this formula. So minus sine lat A. What is lat A? 10 degrees 25 minutes times sine lat B, which is 39 degrees 27 minutes. So here you will input this one to your calcu. So cosine 35 degrees 02 minutes times cosine 10 degrees 25 minutes, and then times cosine 39 degrees 27 minutes, then minus sine 10 degrees 25 minutes times sine 39 degrees 27 minutes. So press equals. So we will get this value. So in order to get your answer, you still need to press shift cosine inverse that value, then answer, then close parenthesis, then equals to get your answer. So AB is 59 degrees 32 minutes. So we have here 59 degrees 32 minutes. So to get your distance, so times that this value to 60 times 60, then here times 60, we'll have a distance of 3572, then round it off to 3, then miles. Don't forget the unit. So that there. So you've got your answer from the great circle distance. Then let's proceed to initial course. So we have a formula here. Initial course A tan lat A over tan P. Then let's input this one to your calculator. Press this one, then tan latitude A is 10 degrees 25 minutes, then tangent 35, which is what is a P again. This is our D long, so 35 degrees 02 minutes. We'll have this answer. So the value of this A, or of your A, is 0.2622 1.8377. So the direction of this one is north, so box your answer. Then so you have your A. So then next is B. So B, what is B? So B is equal to tangent latitude B, then over sine P. So here tangent, press tangent latitude B. What is latitude B? It's 39 degrees 27 minutes, and then over sine P. RP is 35 degrees 02 minutes, which is RD long. So value of that would be 1.433442403. So for your C, you're just gonna minus your A. So north. So in getting C, it's either gonna plus or minus your A and B to get your C. So in this case, since we have both have the same signs, which is north, we gotta plus add that one. So we already input the value of B. So let's add that to 0.26221.88377. So this is the value of your C. (695.661241) north. So here it's either A plus or minus B. So you already got your A, B, and C. To specify this, your A, you have tan So moving on, tan AZ is equal to 1C cos lat A so input this one. So your C is 1.695666124 then times cos latitude A. Cos latitude A is 10 degrees 25 minutes. So here, as you can see, we have I have input RC. So all I'm gonna do is press 1 over answer times cos 10 degrees 25 minutes. So we'll arrive at this value. So easy. You're still gonna inverse tangent this one. So press inverse tangent answer to get your initial course. So Your AZ here would be 30 degrees 56.87 minutes. So I just round it off to get this value. So box this one. Direction if this one is west. So here got our initial course. Then let's proceed in finding the true course of your initial course. So here to find the true course of your initial course, from your answer from 3 degrees, we're gonna minus that one to 360. So 360 minus 30 degrees 56.87. So why 360? So we're gonna analyze your problem. So initial course. So you're from latitude A, south of the equator. So how will you find your true course when you are proceeding to your point B? So we all know that latitude B is at the fourth quadrant. So we all know at a fourth quadrant, what you're gonna do is you'll minus 360 because the direction of your point B is at the fourth quadrant, which is northwest. So that's why you will minus your initial course to 360 in getting your true course. So here from this this is our answer from our initial course minus that one to 360. So we'll have an answer of 329 degrees 03 minutes true. So here we've got your answer from your initial course already. Then let's proceed in getting the final course. So right, final course, and then proceed getting A with your formula, tangent latitude B over tangent P. Then tangent that B is 39 degrees 27 minutes over tangent 35 degrees 02 minutes. So A is, get your calcu. So tangent 39 degrees 27 minutes and then tangent 35 degrees 02. So we'll have this answer. So write that down. So 1.173728746. Then double check this one. So 173728746. So it's correct. So the direction of this one is south. And then proceed to solving B. So the B here is tan latitude A over sine P. So B is tangent latitude A, which is latitude A is 10 degrees 25 minutes over sine D long. This is our D long again. So 35 degrees 02 minutes. So here, so input this one to calculate. So tangent 10 degrees 25 minutes and sine 35 degrees 02 minutes. So we'll have this answer. So input that one, so 0.32024 0.625 south. So box, then you get your value of your B and also your C. Again, it's either you will plus or minus your A from B. So as you can see in this directions, we have both same signs. So you have both same signs, you're gonna add A and B. So C would be, since I have the value of RB here already, just gonna add this one to plus the value of A, which is 1.173728746. Press answer. So the value of RC is 1.493969348. Then double check. 1.493969348. Then box your answer. So next, find your final course in continuing to solve the formula. So C times cos latitude B. Input your from the formula. So 1. So your C is 1.493969348 times cosine latitude B, which is, what is the cosine latitude B is 39 degrees 27 minutes. So get your calculator. So it's already input. This is the value of RC, as you can see. Then all you're gonna do is press on, then this 1 over answer. That's the value of RC. The answer is the value of your C. Then times cosine 39 degrees 27 minutes. Then here, this is the value of your final course. So that doesn't end there. So you still need to press shift tangent to make it inverse, then answer to get your final course. So final course is 40 degrees 55 minutes east. So there we have our final course in degrees. Then we still need to get the true course of your final course. So you can see the value of your final course in degrees is the direction of your final course in degrees is southeast. So if it is southeast, you will subtract that one to 180. So 180 degrees minus 40 degrees 55 minutes east, southeast. Why? You might be wondering why I minus this one to 180. So you can see the direction is southeast. Then southeast, if it lies to the second quadrant, you will minus it to 180. So here, this is the value of our final course in degrees. Just minus that 1 to 180. Then you get your true course of 139 degrees 4 point, and let's just round that one off. So 4.8 degrees minutes true. So here, got your final course already, as final course in degrees and also the true course. and then you will proceed in getting the vertex. So I'm still gonna combine my answer, which is the final course, and which is the initial and the final course. So therefore our initial course is northwest. So north 30 degrees 56.87 minutes, or through course of 329 degrees 03 minutes through, and final course of south degrees 55 minutes east, or 139 degrees 4.8 minutes through. So there you have it, our final course and initial course. Then let's proceed in getting our vertex. Next is we're gonna get our vertex. So here, let's proceed. So in getting your vertex, you will use the Napier's rule. So I'm gonna show you how to draw the Napier's rule. So here in PAV, angles PAV, using Napier's rule. So draw your Napier's rule. So draw a circle. This is our vertex. Then draw a X, and then a one line here. So this is our vertex, this is our P, this is our AV, and then 90 minus P, 90 minus PA, 90 minus A. So there, this is our Napier's circle. And then proceed in getting those your values. So your values here is this is from the initial course. So our A is initial course of 30 degrees 56.87 minutes, and then PA, still gonna solve PA on now, and then how you will solve your PA. So PA 90 degrees 90 minus your latitude A. So latitude A is, so latitude A minus 1025. So 25 minutes. So 10 minutes, 25 minutes, 10 degrees 25 minutes minus 90, we'll have answer of 79 degrees 35 minutes. So this is the value of your PA, and then also write your latitude A, because we'll use this one. So 10 degrees 25 minutes. So here, with the use of the Napier circle, let's write the formula in getting the vertex. So here, sin PV cos 90 minus A times cos 90 minus PA, this one, PA, 90 plus PA, then sin 90 minus PA, sin then tangent 90 minus a times tangent 90 minus p. So simplify, so cos latitude of vertex, so sine a times cosine latitude a. So here we have what is our sine a? What is our sine a? So sine a, we'll input this one, so sine 30 degrees 56.87 minutes times cosine latitude a. What is our latitude a? Cosine 10 degrees 25 minutes. So cos latitude v. So we're gonna use our calculator. So sine 30 degrees 56.87 minutes times cosine 10 degrees 25 minutes. So we have this value. So we still gonna inverse shift cos answer to get your latitude of vertex. So here, so latitude of vertex is 59 degrees 33 minutes. So here, let's double check. So here 30 degrees sine cosine 10 degrees 35. So shift cos. So let's just round this one off to 59.37. So here, round this one off. I'm gonna round it round off. It's north. So there. So we've got our latitude of vertex. Now let's proceed in getting your P to get your longitude of vertex. So next is tangent P cot A times secant PA. So tangent P, so in the calculator you will need to reverse cotangent and secant. So the reverse of cotangent is tangent, then the reverse of secant is cosine. So what it will be 1 over tangent A. What is A? Again, 30 degrees 56.87 minutes times the inverse of secant is cosine, so cosine PA. So what is PA? It's 79 degrees 35 minutes. So input that one in your calculator. So 1 over tangent 30 degrees 56.87 minutes times cosine of 79 degrees and 35 minutes. So you will have this value. So you still gonna shift tangent, inverse that value. So we've arrived at answer of, so our P here is 83 degrees 48. As you can see, 83, 48. I'm just gonna round this one off, so 48.74 minutes west. So now we got our P, so let's solve for the longitude of vertex. So from D long, from A to V, it's 083 degrees 48.74 minutes west. So longitude A, so the longitude A, gonna find longitude A from here, and it's 90 degrees 12 minutes. So 090 degrees 12.00 minutes east. So longitude of vertex. So since we have these different signs, we're gonna minus this one. So 83 minus 90 degrees 12 minutes. So we'll have an answer of 6006 degrees 23 point. We're gonna round this one off, so 26 west. So there, got your answer 006. So since we've got our latitude of vertex and also the longitude of vertex, let's proceed in getting the GC track. So we all know when GC track crosses equator, as we know, longitude in GC crosses equator is equals to 90 degrees D long from the longitude of vertex. So here, as you can see, so longitude of vertex is 005. This is 00 degrees 59.30 minutes west. Then the D long from V to N is 90 degrees 00.00 minutes east. So it's the answer of that one. Since we have different signs again, minus that, so 0.05 degrees 59.30 degrees minus 90. So you have answer of 084 degrees 00.70. So here east. So label this one as GC track crosses equator. And then to get the course after crossing the equator, latitude or vertex is equal to north 30 degrees 23 minutes west. So here, let's complete our GC track. So here, as what I plotted a while ago, I first draw the latitude A, latitude B, and also the D long. This is our D long. This is North Pole, so the D long will be located at this part. So 35 degrees, 02 minutes, and then let's locate our vertex. So where can you plot our vertex? So we have rules to follow in plotting our vertex. So in this rule, so if B is bigger than 90, vertex is after B. So this rule. So if B is bigger than 90, vertex is after B. So if you, as you can see in our problem, since our latitude A is smaller than smaller than latitude B, so this falls from the third rule. So the vertex will be after B. So after B, so the vertex will be here. Extend your GC track, then label this one as your V. This is your vertex. Then what is the latitude of your vertex? So 5937. So 59 degrees 37 minutes north, and the longitude of vertex is 006 degrees 23.26. 006 degrees 23.26 to 23.26. And then from your equator, from the North Pole to the point of where you crosses the equator, this point, I'm gonna label it this here. This would be your N. So your N, already plot your N here, then A from vertex, latitude A, latitude B, then your N. So let's check if we completed our this problem. So as you can see, first things first, D long, we find our D long, check. Then also degrees, distance in degrees, check. Also the distance in miles, so check. Initial course, check. True course of initial course, check. Final course, check. In degrees, check. In degrees, and also the true course, check. And then next is finding your vertex with the use of Napier's rule. So here, Napier circle, use of cosine law again to find your vertex, latitude of vertex, check. And then to find P, in order to get your longitude of vertex. So P is check, then longitude of vertex, check. And then the GC track, so minus that one to 90, so check. GC track crosses to equator, so no. So this is your the complete answer of this problem. So thank you guys for watching. I know great circle selling is a very long process, but you'll find it very challenging. Well, I hope you learned something, and subscribe for more videos. Thank you for watching, guys. God bless.